Two and a Half Admins, episode 57. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And your plug this week, Alan, is using the free BSD rack TCP stack.
Yes, our network expert has written up this nice article explaining how to use FreeBSD's multiple TCP stack feature and switch over to the rack stack for certain workloads where it might be better than the default TCP stack.
Right, well, link in the show notes as ever. Something that caused a bit of controversy recently was about WhatsApp's end-to-end encryption. This came from a ProPublica.org article, and you wrote about it, Jim. And I've seen people call this original article trash, and I've seen other people say that it's spot on. So I'm a little bit conflicted on this, I must say.
Kind of depends on where you're standing. Both statements can be true. There's a lot open for interpretation in what they meant or what was said or, what the impact was. But basically, the detractors from the ProPublica article and for that matter, from my article point out correctly that WhatsApp does not break end-to-end encryption. You are truly encrypted from end to end. The problem is that WhatsApp bills itself as though it's as secure as, for example, Signal, which is a zero-knowledge end-to-end protocol. WhatsApp is not zero-knowledge end-to-end. And the other thing is, you have to really look at that word end. What does that mean? Your two ends are both owned by Facebook, aka WhatsApp. So kind of the proof in the pudding that end-to-end encryption does not mean that Facebook can just, grass you to the cops or whatever, is in the fact that turns out they employ, 1,000-person contracted moderation team specifically to inspect the content of messages. The reason they can do that is because, like I said, those endpoints themselves are still controlled by Facebook/WhatsApp. Right now, there's no indication of anything screwy about that, in that the only time that they can inspect the content of those messages is when a user actually reports it. So what happens is you have a conversation that you're not enjoying on WhatsApp and you hit the report conversation button, and it doesn't make it very clear what's going on, but what actually happens is it sends the last 5 messages in that conversation off to Facebook to be analyzed and decide what they want to do about it. So again, we're in a case of yes, you legitimately do have end-to-end encryption, but that's not the whole story. Where is the end? I want to be very careful about the way that I talk about this because I don't want to accuse Facebook of something that it's not doing. But at the same time, it's important to point out connotations and possibilities for the future. Now, the fact that you've already got an application that is specifically designed, there is a function in place to just relay these messages right off to Facebook to look at, that very heavily implies that although right now the user has to click a button to make that happen, at some point in the future, Facebook could very easily go the Apple route and decide, no, we need to scan everything for bad stuff. And we can do that without breaking end-to-end encryption because, again, the ends are still within Facebook-controlled territory, meaning those apps running on your device on either end that are still closed source proprietary apps that Facebook puts out. So they can kind of do whatever they want until somebody reverse engineers it and decides they don't like what they're seeing.
And Facebook did point out that the messages that get forwarded to their moderation team as part of the report are also end-to-end encrypted to that moderation team.
Sure, but the whole point here is that saying we've got this really super secure app and you don't have to worry about your privacy has some unavoidable implications to normal people who are going to use your app. Normal people using that app are not thinking, okay, well, it's end-to-end, but, what about after the ends? That's something that an InfoSec person absolutely will immediately think. But normal people are just going to say, oh, okay, this is one of those super secure things, and, my privacy is going to be fine. Now, because right now the report function is, of course, tied to, somebody actually clicking report, the argument is that there's no difference between that user taking a screenshot and saving it that way. I would argue that there is still a definite difference in that if a user takes a screenshot and sends it on, whether it's to report it or share it with a friend or whatever, yes, that information has leaked, but that is really and truly the person that you sent it to very directly that's doing it. They have to leave the application to do it. They have to engage in third-party tools. Whereas here, we've already got a function built into the app specifically to relay these messages on the far end of the end-to-end encryption off to some place that you might not want it to go.
Yeah, and like you're saying, it's not necessarily obvious, even to the person doing the reporting, what's actually happening. In a maybe better designed user interface, when you hit report, it would give you a preview of what it's about to send to Facebook and be like, we're going to send this off to the WhatsApp moderators to look at. Are you sure there's nothing in here that you don't want to get out? Because, even as the person reporting it, if you thought it would just send, hey, this person's being a dick, not here's the conversation we were having, you could end up violating your own privacy by trying to report somebody being nefarious because you don't get to pick what messages get sent.
Yeah, and to be clear here, this is another thing that, there's been a lot of confusion and sturm and angst about. I am not against the presence of a report function in the application. My issue personally entirely revolves around the messaging. I think that WhatsApp is a perfectly appropriate, consumer-friendly, reasonably private tool for people to have low-stakes communications over. But the issue here is that that's not really how Facebook markets it. They really, really, really amp up that privacy and security angle to the point that whistleblowers who are in danger of losing, their jobs or possibly even their lives think that WhatsApp is okay to use. Well, it's not. We had whistleblowers in the Trump administration, one of whom is doing 6 months in prison right now because she thought WhatsApp was secure enough to leak some documents, and nope, sure wasn't. FBI did a subpoena. And the other thing is, the content of your messages is end-to-end encrypted. But again, unlike Signal, the metadata is not. So the FBI treats it as being basically just like an old school POTS line, an old telephone line where you can very easily just subpoena the phone provider and get, they call it a PIN register request. And you just immediately get all the people that have called your target or your target has called within a certain time frame. You don't know what the content of those calls was, but like in this case, again, this is how the official who's, doing 6 months time right now got busted. She leaked documents via WhatsApp to BuzzFeed. And when the FBI investigated her, they just subpoenaed Facebook and said, hey, we want all the metadata for this user on this time. And then said, this person had 70 messages back and forth with a BuzzFeed reporter on the day that this report went live. So they didn't necessarily need to see the content because, then the question is like, well, the hell else were you talking to that BuzzFeed reporter that you never started talking to before this time frame about that required these 70 messages? The content's kind of unimportant at that point.
When you think about it, that's Facebook's entire business model is knowing who you're talking to and how often. So of course they want that information. So even with a better app that has zero knowledge and end-to-end encryption, you also still, like we were saying, have the problem of you send an encrypted message to someone, that person can turn around and send it to someone else, encrypted or not. And that's another thing you have to consider.
Right. But like, for example, if the same FBI agent tried the same approach with a Signal conversation, the only thing Signal would be able to tell that FBI agent is this person received 70 messages. They wouldn't be able to say where they came from, which is an enormous freaking difference. And if Facebook wanted to provide that level of privacy and security with WhatsApp, they could have. They did not want to. There are documents from when Facebook initially purchased WhatsApp. Remembering, Facebook didn't create WhatsApp, they bought it. And there are documents with the initial conversations between the initial developers of WhatsApp who pretty much rage quit because they didn't like the direction Facebook was taking it. Zuckerberg's like, hey, how do we monetize this? He initially wanted to do the same thing with the messages there that Facebook does with everything else on Facebook. Let's scan all this for content and do targeted advertising, the whole nine. And enough people kicked up their feet that didn't happen. I'm not saying that is the case now with WhatsApp. It is not the case. Everything truly is end-to-end encrypted. And at least for now, that data never goes to Facebook. The actual content now, not the metadata. The actual content doesn't go to Facebook unless somebody reports it, so it's not being monetized. But again, that was the initial thought process behind the whole thing.
Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, It's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. Let's do a bit of feedback then. An anonymous person wrote to us and said, I actually solved the issue of blocking YouTube a few years ago using deep packet inspection. The child was not able to access YouTube on any channel he was used to, and I could easily control the timing. Even after 4 years, he never figured out how to bypass it. All I needed was an edge router light.
I don't know if it's still that easy. Like, even if you go the full way of having, doing the SSL intercept with your own certificates and so on, Android devices resist that type of thing pretty heavily now.
The listener wasn't real concrete with the details. All they said is solved it with deep packet inspection, and maybe you can manage that, maybe you can't, but you're going to need to do some deep packet inspection, and you're going to have to do it in the initial connection sequence where you make the HTTPS connection to YouTube. And I don't believe you're actually going to be able to break it after that, which would mean that, again, assuming I'm correct, because we didn't get a whole lot of details about how they're doing this with their edge router light and deep packet inspection. If I'm correct and they're looking for the signature of making the initial HTTPS connection to YouTube to begin with, that also strongly implies that if your kid just started watching a 3-hour movie and right then the YouTube block goes in, it's not going to interrupt their stream because the HTTPS has already been negotiated.
They weren't very clear about how long ago this was, just that they used it for about 4 years. Back in the day when YouTube wasn't HTTPS, it was relatively trivial to be able to detect connections to YouTube and block them. If you just never let them load any pages at YouTube, it's pretty hard to, like Jim was saying, even get to start the video where it becomes hard to interrupt it at a certain time. And yeah, like Jim said, doing it time-based is very difficult just because blocking the page won't necessarily stop the already open connections. So other than just cut the internet off completely at a certain time of day, which is relatively straightforward, it is very difficult to block individual sites now.
To expand on that a little bit about the TLS negotiation, most of the TLS negotiation when you start connecting to a secure site like YouTube actually happens in clear text. In particular, if you know what certificate YouTube is going to provide, then you can just look for that certificate to float over the wire and say, nope, whenever you see it. And that will prevent the TLS negotiation.
Yeah, the SNI where the browser tells the server which site it's looking for in the host header. So that site, when it hosts multiple SSL sites, can return the correct certificate. That was a leak. I think that's fixed in a newer version of TLS, but I don't think everything's switched to that yet. Or I think it's only going to be in like 1.4. That's not even official yet. So there's that information leak in SNI in at least TLS 1.2. I'm not sure about 1.3, and it's supposed to be fixed in whatever the next one's going to be. But that's a good point. Like you were saying, Jim, it still doesn't help you cut YouTube off at a certain time of night.
SNI or no SNI, the server certificate goes out in the clear. So if you know what certificate YouTube is using in the hello process, then you can't complete a TLS hello if you're doing deep packet inspection and saying, if I see this certificate, then I'm going to do a TCP RST on that pipe, then you'll never be able to connect. But the hello only happens while you're initially negotiating the connection. Once you've actually negotiated it, you're good to go for as long as you like. I believe you'll even be able to continue watching other streams with it. You wouldn't be able to open a new browser window, but as long as you're in the window and you're literally just clicking links on YouTube, you'll have to renegotiate the ephemeral stuff every now and again, but that's not something that you can detect from the deep packet inspection. You can just check the actual certificate, which is like if you ever do a wget from the command line and you think you're going to look for an HTTP site, but it ends up being HTTPS, and you just went by raw IP address and it says, oh, hey, the certificate doesn't match. You can try again with -- no check certificate if you want to fetch this anyway. That kind of gives you the idea of what's going on. Like you can see the server certificate that says, hey, I'm YouTube. So if you're doing deep packet inspection, you can just say, anytime I see that certificate float down the wire, break that connection. But again, once you've done that authentication, you're good to go for that session.
Yeah, and a lot of the performance of modern websites now is, hey, once we got that connection, we're going to keep it and we're going to have fast resume on it and so on, and not, close that connection as soon as you finish loading the pages. And then when you click the next link, we're going to have to open a whole new one and do all that negotiation and verification over again. And so that's the thing that's going to make it. This method works great for blocking YouTube outright if you're, at a school or something and want to do that. But to just say, after 9 p.m., no YouTube, it gets very complicated when there's ongoing connections, unless you're literally just going to do at 9 p.m., the internet stops working and then resumes, but with certain sites blocked or something. If you just flush the whole NAT state table or something and close all open connections.
Let's do some free consulting then. But first, a thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. Okay, Steve says, any opinions or pros and cons on Intel's Optane memory? Not SSD storage, RAM. Dell is pushing a config that includes 1.5 terabytes of Optane DIMMs with 384 gigabytes of regular DRAM. The upshot is that it's the same cost as 768 gigabytes of regular RAM, but runs at 2666 instead of the 3200-ish you get with DRAM. I'm skeptical, but maybe that's just the grumpy old man in me. Any war stories to share?
You kind of covered the whole thing there. That's a lot of what Optane boils down to. It is not as expensive as RAM. It's not as fast as RAM. It's more expensive than NAND storage. It's faster than NAND storage. So it's just kind of a case of, picking where your trade-offs are. Now, most people that I talk to think of Optane as being more on the storage side than on like the server RAM side, just kind of based on, the quantities of it that you're putting together. But how you're architecting your system is really just going to depend on what you want out of it. Do you need a whole lot of basically RAM, but it's kind of slow? Well, then Optane's going to be cheaper than the same amount of actual RAM.
So I've had some limited experience with actual NVDIMMs where a server with like 768 gigs of RAM also had 32 or 64 gigs of NVDIMM, which is basically fits in like a RAM slot, but shows up as NVDIMM storage. And kind of like this Optane is not as fast as RAM, but is bigger than RAM and is faster than SSDs, but smaller. And we used it for the ZFS slog. Basically, the write cache was going to this really fast, medium-sized device. And then the whole pool was all SSDs. But it meant that the database transactions took microseconds instead of milliseconds or whatever.
Yeah, and that's another one of those areas where that's exactly what we're talking about, where you need something that is considerably faster than regular NAND flash, but it's still not going to be as fast as RAM. Now, in the case of the ZFS slog, the other really important part of that is specifically the persistence, because there you are treating it more as storage. And there's two major ways that most people will differentiate storage and memory. And, those two ways tend to be how fast is it? Memory is the fast one, storage is the slow one, and also persistence. The trade-off for how fast that memory is if you yank the plug out of the wall, it all goes bye-bye, whereas you expect the data on your drive to stay. So Optane splits all the differences, basically. It is considerably faster than even very fast solid-state storage. It is persistent like that storage. It's faster than that storage, but it's still not as fast as real RAM. You're just kind of left with like, okay, do you have a good use case for that? The ZFS log device is an excellent use case for that because you need the fastest possible latency to acknowledge that, yes, you have gotten this important piece of sync data and you have committed it. It's now safe to move on with the operating system's life. Optane is perfect for that. As far as I'm aware, there's literally nothing else that beats it for that. But that is a pretty specialized use case.
Well, and specifically, you only need like 16 gigs of that at the max, probably. Sometimes you can't get that little, and so 32 or 64 is what you can get. But in the specs you were talking about from Dell here, you're talking about like 1.5 terabytes of it. So you wouldn't want to use all that for slog because it just wouldn't get used. And so you could have that as some kind of cache or something, but it really comes down to what's your use case for that?
When I was looking at reviews for my motherboard, which supports Optane, they gave me the impression that it was more about speeding up spinning Rust drives. Like if you're going to have spinning Rust drives in your desktop machine, then a bit of Optane will give you better performance from them.
That's an example of, kind of a shoehorned application. So basically, if you're a consumer and on the Windows side, that's the way that Intel has marketed it heavily to the OEMs who will target those consumers. So you get a very, very tiny, typically, Optane. They call it a DIMM, but really it's an NVMe drive is what it boils down to. But it's usually like 8 gigs. I mean, it's just laughably tiny. And the idea is that it will act as a transparent cache layer, both read and write between you and slower storage. There's an application like already built and like ready to install that's kind of presumed to come with it to allow you to use it for this use case. But at the end of the day, it's just an NVMe drive with these peculiar characteristics. Also, at the end of the day, honestly, a very small NVMe cache for a slower drive is not frequently as useful as people really hope it to be.
It's why the hybrid hard drive SSDs didn't take off 10 years ago.
Exactly. I have actually played with Optane in the way that it is intended to be used on the Windows consumer side a few times. And just like the hybrid SSHDs from 2012, as far as I'm concerned, they do effectively nothing in that role.
Yeah, like basically your two use cases are use it as the write cache, so it's like the bit of SLC on a lower end consumer SSD, where the first so much that you write to it will go to the fast device and then trickle out to the slower device. And it's like, okay, great, but I wasn't really worried if I had to wait an extra couple seconds for that file copy to finish. And then for the read, if a big cache worked, then the hard drive would just have a bigger cache. The problem is you're randomly reading all over your hard drive. It's not really possible to predict what you're going to read next and pull it in from the drive and have what you're going to use be hot. And so it's basically a software version of the hybrid SSDs, and it's probably not that useful. Now, in underpowered machines, it might end up being used basically as fast swap. But, if you're swapping, you're already tossing most of your performance out the window anyway.
Yeah, by the time you start to swap, everything sucks already. It's all downhill from there.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Okay, Matt writes with quite a funny one. Assume the following 2 utopian statements are true. Number 1, humans don't steal shit from each other, so there are no security concerns. And number 2, drives don't fail. So, given those 2 statements, what would be your top 3 admin tasks? In short, how much of an IT pro is dealing with circumventing failure and theft?
Well, if we assume both of your postulates are true, the top 3 IT tasks are going to be making certain that your chickens are perfectly spherical, your vacuum is uncontaminated, and all of your surfaces are entirely frictionless. Past that, you're good to go.
In general, I guess it would be designing and deploying new things, upgrading stuff. Even if we don't consider security advisories and bug fixes to be a thing anymore, there's still going to be new features you want. And so you're still going to install newer versions of software and operating systems and so on. And so managing those processes and, don't even get me started on, upgrading apps that involve databases and schema changes and making sure everything actually works after the upgrade. But yeah, a lot of it, I think, would still come down to lifecycle management. It's deploy the new things, keep things up to date, and decommission the old things and properly recycle them. A lot of that does come into the security and so on. And hopefully in this utopia, you don't have to deal with making sure there's not data left over on the drives before you recycle it or whatever, but you still have to manage the life cycle of the machines and planning when you're going to need more capacity, when you're going to need new machines, when things are out of warranty and you need to get new things. A lot of it comes down to that.
When some random C-level took lunch with some salesperson and, now you randomly have to change out this entire software stack for no better reason than the shrimp was really good that day. I think there's an untrue implication in the original question, even moving beyond the spherical chickens. Alan, I think you would probably agree with me that most of our day-to-day role as system administrator already is not about equipment failure or a major security problem. Mine is not. Mine has a lot more to do with integrating systems. Oh, God, I'm going to sound like such a corporate drone. Most of my day-to-day work is system integration that allows the software stack of an organization to better model its business workflow. It's really what I do. It sounds like horrible corporate drone speak, but you kind of sum it up as, make things work the way that people want, expect, and need them to work and to make them more productive.
That's the whole reason why they pay for the computers, is to get work done.
Yeah. Failures and security issues and whatever, those are the occasional, oh crap, time to go, pee voluminously on this fire kind of a thing. And it's something that you hedge against, with a lot of planning to make sure you're not deploying something that is fragile or likely to be compromised. But that's not the everyday. If you want to talk to people that's their everyday, that's not sysadmins, that's InfoSec folks. That's somebody on a blue team or a red team where, the red team's job is literally to just try to pratfall the blue team every single day, attacking their own infrastructure, which makes sure the blue team keeps busy because they know for a fact there's always somebody attacking their infrastructure.
Although, if you have enough hard drives, you will have drive failures like every single week.
Maybe you do. I don't.
Well, I oversee a lot of people's storage, so I see a lot of drive failures, but they don't really take that much of my time. It's like help them identify the right drive, swap it, come back later, make sure the scrub finished or whatever. It's not that big of a part. So yeah, I think for mine, it's a lot of life cycle stuff. Just stand up new machines, get them working, keep them working, and then decommission the old ones. A lot of it is planning. Like, all right, we built this storage server last year. It's 70% full now. We need to start planning how we're going to make it bigger before we run and get those parts in and installed before it runs out of space.
Getting the people who are going to pay for those things to understand what those things are, what they will cost, why it's worth paying that cost. If that cost is not palatable, what a better option is, and what trade-offs go with that option.
Oh yeah, and there's a chip shortage, so that the machine you ordered is going to take 3 months longer than expected to ship.
Oh, don't get me started on that crap.
Yeah. It's like we got all the hard drives for the new storage server, but it doesn't have a processor. Or,
we've got the processor and the board and everything, but it's going to be another month for the hard drives because, some jackass made a new cryptocurrency called Chia that, eats up storage more than it eats compute. So now there's a run on that. Thank you, crypto nerds.
The worst part about that is that crypto nerds used to mean something different.
Yeah.
People that did actual cryptography and more fits with the message encryption topic. But anyway, so top 3 admin tasks, I think, is the lifecycle stuff. And like Jim said, the biggest one is serving the goal of the business. For different people, that's different things. In my old day job, it was keep the storage working because we're streaming video and it's all about the storage. It's keep the storage working and keep the network working. And everything else is kind of secondary. I would say planning and capacity management, lifecycle management of the machines, and so on. And yeah, in the end, dealing with hardware failures, including things other than drives, is usually not that big of it. If you've done the planning right, then it's not an emergency when a power supply fails or some hard drives die. And that's really what your job is, to make it so that as few of those things that can happen or are definitely going to happen someday are not emergencies. In the end, the security stuff is usually there's only a couple things a year where anybody needs to get excited.
You know that you've done a really good job with that when your reaction to one of those emergencies is not like a cold sweat. It's, oh, goody. Because, I get to go deal with a ransomware thing. Like, I know exactly what I'm going to do with that. I know just how this is go. I know for a fact it's going to be all fine when I'm done. This is kind of fun. I get to go actually do it instead of just having planned for it. Like, that's when you've really done this kind of job well. When you're like, okay, I've built and planned out this whole thing so that failures, A, rarely happen, and B, when they do, oh, fun, it's a field trip.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send in your questions or feedback. You can find me on Twitter @Joe Ressington.
You can find him @Alan Jude.
And you can find him @JRSSNet.
Yes.
See you next week.